Stanford University.
Okay, well, welcome to Lecture 16 of Stanford CS193P, winter of 2015. So today we're going to be talking about three major topics. One is the camera, how to basically take a picture with the camera or get video from the camera. Then persistence, which is an important topic about how to store stuff in the flash memory of your phone. And a lot of you have already kind of dived into this as part of your final project, but I'm just going to kind of give you a tour of the various ways that can be done. And then the last one is kind of an interesting segue. I leave it for last because it's kind of requires you to be a little bit of a visual thinker to see what's happening when we do it, but it's called an embed segue, which is where we basically take one MVC and we embed its view into another MVC's view hierarchy, which is kind of fun. So let's dive right into the camera. The camera is accessed via this file or this class called UI Image Picker Controller. It is a UI view controller, okay, subclass actually of UI navigation controller, I believe. It's very simple to use. You really just configure it and then you put it up modally, okay? There's really nothing more to it than that. We learned about how to put things up modally last time with present view controller. That's all you're going to have to do. So the process of using the UI image picker controller to get something from the camera is you create it and you set its delegate. It won't do anything without its delegate, so you have to set its delegate. Then you're going to configure it for, do you want just still images or video or that kind of stuff? Do you want users to be able to edit the pictures they've taken before they import them into your app, etc. Then you just present it with present view controller. And then you're going to respond to delegate methods that tell you, okay, I took a photo. Here's the image data or the video, the URL of the video that the user took. So that's pretty much it. Each device kind of has different hardware, although that's becoming less and less true as the years go by. It used to be that there were some iOS devices that didn't even have a camera at all. But certainly there were early on iOS devices that could do still images, but couldn't do video, for example. So as with all the hardware things, whether it's core motion or any of those things, we always want to ask and see what we can do first. So it's very easy for the image picker controller. It has a class function called isSourceType available, and there's three different sources for images or video to come into your app. One is the camera, obviously. Another one is the saved photos album. That's essentially the camera roll, right? Things that they've taken with the camera. And then there's the photo library, which is the same thing they see in the Photos app. Okay? So you can kind of pick which one of those things you want to get your image or video from. And they're a little bit different. Well, the photo library and the Save Photos album are treated pretty much exactly the same, but the camera is a little bit different in how it's presented. So we'll talk about that in a moment. Once you know your source type, then you're going to say, what are the available media types? Image or video? Or both. Now, it's almost not even worth checking for image anymore because if you have a camera, it can get an image. So I think it'd probably be okay if you just never even called this available media types for source type camera if you're trying to get an image, okay? Because it's going to be there. But if you want to get video, you definitely should call this in case someone has an older iPhone that doesn't capture video. Now, these two types, the KUT type image and KUT type movie, which are basically strings, that specify these two media types. Strangely, they come from this framework that you're otherwise never going to import, which is the Mobile Core Services framework. So if you want to use those two types right there, or these two constants, KUT type image and movie, you need to import Mobile Core Services. Okay, I'm kind of lingering on this one because this is something people forget, and they're just like, what the heck? Because if you search in the documentation, it's kind of hard to find that you're supposed to do this, whatever. So I've made a special slide and emphasized it there for you. You can obviously ask the UI image picker controller for more detail even than this. Is there a camera and what kind of things can it take? You can say, is there a front camera? Is there a rear camera? Which you might care if you have an app that's like selfie oriented. It might want to know that there's a front camera for that. And you can also tell whether a flash is available on that device, etc. So there's a bunch of class functions in UI image picker controllers. You can find out what's going on. So here's the code typically to prepare to present the picker. You're going to create the picker, you're going to set its delegate, you're going to ask if the camera is available. If it is, you're going to set the source type to be the camera. Then you're going to ask and see if, for example, in this case, I want to take a movie with my camera, so I'm going to ask, is that KUT type movie available? Now, this line of code right there, if available types as an NS array, parentheses, dot contains object, parentheses, KUT type movie, that's kind of a weird line of code, really doesn't fit into the Swift world very well. You just do it. It's just it's an old Objective-C based API, and KUT type movie is even kind of an older kind of string even than NS string. And so we kind of have to do this old style thing. I'm sure probably in the iOS 9 or iOS 10 somewhere they'll probably come up with some new API for this whole camera thing that doesn't have this old stuff. But for now you have to do that. And then you just tell the picker, okay, the media types I want the user to be able to take is just a movie. So then in this case they wouldn't be able to take a still image. They would only be able to take a movie if you pass an array with just KUT type movie. So that's it. You've configured the picker now. You just need to present it with that present view controller. There's some other things you can kind of configure with the picker before you put it up. One is editability. That's whether you're going to allow the user to crop the image or edit the video. There's actually a video editor built in there that they can edit the video before it returns to your app. You can also limit video capture, for example, to be kind of lower resolution. If you're just doing something that's going to be in a little square somewhere in a web page, you could go low resolution. If it's something that maybe is going to be airplayed to a high resolution device or something like that, then you can go for higher resolution. Of course, higher resolution, you're going to use more memory, et cetera, et cetera. Okay. You present it using present view controller. Now, the thing about this is interesting is when you're doing the camera, you're always going to present view controller. It's always going to be take over the screen, even on the iPad. So on the iPad, when you do the camera, you're going to have this huge camera taking picture, okay? The whole screen is going to be the camera. However, on the iPad, if you're just looking at the photo library, okay, or the camera roll, you want to present that in a popover because it's only going to be fairly small, like, you know, 320 wide by, I don't know how high, 600 or something. So that's really something you're supposed to put in a popover. Now, on an iPhone, it doesn't matter. In both cases, it's going to be full modal take over the screen, okay? Because it's just too big to put any other way on the iPhone, okay? So you present this thing, and it sits there on screen, and then when the user picks use this photo, okay, or use this video, this is going to be called right here, this delegate method. Image picker controller did finish picking media with info. And the with info dictionary there has the results of what they did, okay? And when you get that, we'll talk about what's in there in a minute, but when you get this and you get your image or whatever, then you want to dismiss this thing. And I've kind of put here a line of code, presenting view controller dot dismiss view controller animated. Usually you're not putting the presenting view controller in there because you are the presenting view controller. You just presented this thing, so you wouldn't need that part of it. But I just want to emphasize that, again, you dismiss by sending a message to the presenting view controller, which is probably going to be you. And you'll see in the demo, we're going to do this, and we're just going to call dismiss directly. We don't have to say presenting view controller. The other delegate method you're going to get of interest is image picker controller did cancel, and that means they hit cancel. So now you don't want to use the image that they were taking, whatever. So in that case, you just need to dismiss. Okay? So that's it. Those are the two delegates methods you get. So let's look in that info dictionary, see what's in there. All kinds of stuff in there. There's the image they took, obviously, if they're taking a still image. If you allowed editing, then it's going to have also the edited image, like cropped, right, if they picked a different space of it. Also, if they cropped it, you'll get the rectangle that they chose inside the thing. If it's a video, then you're going to get this media URL. Okay? It's just going to be a URL to some file somewhere in your sandbox, which I'll talk about sandbox later today, that points to the video. Okay? When you get this image or video, you might want to save it. We're going to save it in our demo to a file in the file system because I want to show you how the file system works. But really, most likely, you're going to save it to the device's photo library. Okay, that's probably, if someone takes a photo and you want to save it, that's likely where you would store. You might store it in the file system, but more like in the photo library. And you do all that with this. I'm not going to, for time reasons, cover that, but you can check out this class AL Assets Library. It's pretty straightforward how you access the Assets Library, and you can put things in the photo library there. By the way, the UI image picker controller is kind of an old API. It's a simple way to get things with the camera, but there's a whole much more powerful API called AV Capture Device. Especially if you're getting video, you might want to check into that. It's kind of a more powerful way to do the stuff that the UI image picker can do. So I'm not going to cover it, but just so you know that it's there. If you're just getting simple image or just a simple clip of video, you're okay with UI image picker controller. But if you want to do more with that, then AV Capture Device. The last thing about UI image picker controller is that it does support putting overlays. So when that camera is on screen and the user is trying to take a picture, you could have your own controls on there, your own buttons or whatever you want using an overlay view. The camera is always full screen, of course, so you need to make sure that the view that you're putting overlay matches up with that screen's bounds, which you can get using the UI screen class's bounds. You might have your controls actually have the take a photo button, in which case you might want to hide the take a photo button that comes with the camera. And you can do that with show cameras control equals false, and then it won't show its take a photo button, but then you better provide one because they won't be able to take a picture otherwise. And then finally, you have this camera view transform. Normally, the camera maybe takes a square picture, or it might take its picture in any case that the aspect ratio doesn't match the aspect ratio of the screen, but you might want it to basically take a full, basically take the piece of it that is the aspect ratio of the screen, and you can do that by controlling the transform of the camera view. So affine transform there, remember, affine transforms are scale, rotation, and translation, and so you can do the scale there to scale it up if you want to do that, right? All right, so that is the image picker controller. Let's go ahead and go back to our tracks demo and use the image picker controller to make it so that if we have a waypoint, one of our custom waypoints that we now can edit, that we can add a photo just by taking a picture with the camera, okay? That's what we're going to do here. So let's go back to tracks. Here we are in tracks. Just remember where we are here. We've built this thing that allows us to click on the map, and then we can see the images, and we can also drop a pin, and when we click on the little detail disclosure, we bring up this little view controller right here where we can edit the name and the info. So what I want to do here is actually use this nice big space we have at the bottom of our editor to show and edit the photo, okay, that goes along with this waypoint. Now, you might think the first thing I'm going to do here is go down to my object palette and grab an image view down here, but I'm not going to do that, okay? And I'm going to show you kind of a little bit of an interesting trick about image views. One thing about image views is that they have an intrinsic size. They're like labels. They want to be the size of their image, okay, for auto layout purposes. They strongly want to be that size. Yeah, question, sorry. Oh, no, I'm not. Good question. Let's see here. Close. Save that. So you guys are only going to get it from starting from here, because I'm not going to go back to the start. I haven't said much. Okay, so if I have auto layout and I drag an image view in there, then when I set the image, it's going to want to make the auto layout huge because the image is going to be big, especially if I had a high resolution photo. So I don't want that to happen. I want this image view to be the size I say it's going to be. Basically, I want it to use whatever space is available and no more. So kind of a cool way to do this is to use a generic UI view. So instead of taking a UI view, I'm going to pull a generic UI view out here. Now, by the way, when you put a generic UI view out, sometimes it's hard to see what the heck is going on because it's white on white. So a lot of times when I do that, and I think I might have mentioned this before, I'll just set it to some other color for a moment so that while I'm editing it here in the storyboard, I can size it and set up its constraints and all that stuff, and I can kind of see what's going on. Okay, so let's put this thing in reasonable spots over here. Let's set some constraints for it. Put some vertical spacing to the top there. We'll trailing over to here. We'll put this guy over to here, and we'll put this one down to the bottom. And we used to have a constraint on this one to the bottom, which we want to get rid of. Where is that? Bottom space to bottom layout. This one. And we could also, while we're here, make sure this is standard value. Okay, so that looks good. This guy also standard value. All right, so we've got this UI view in here, and really what we're going to do is put the UI image view inside of it, and I'm going to manage it manually. So I'm going to size it to the right size that I want in code. Okay, and that way it'll never be trying to fight the auto layout system to make things really big and smash other things off the screen or make my popover really gigantic or things like that. Okay, so let's go ahead and do that. I'm going to go over here. I'm going to go back. This is our editable waypoint view controller, the view controller for this whole thing. So I'm going to go down here. Let's create a new little mark for images. Okay, so this is our image handling area right here. So I'm going to control drag from this generic view out here. This is not my image view. This is my, what did I call it? Container? Yeah, image view container. Okay, so this is going to be just a generic UI view, see, that contains my image view. And so my image view is actually going to be something here that I create in code. I'll just say equals UI image view, actually. Okay, so there's my image view, and on my did set here, when this thing is set, I'll go ahead and put that image view into this thing by just saying image view controller, add subview, image view. Just capitalize this for me. Okay, so I basically just put that image view in there, and let's see, what's the problem here? It's, oh, image view container, yeah. Thanks. Image view container. I'm used to typing that controller. Let's make this bigger too, by the way, so you can see what we're doing. Okay, so everyone see what I did there? I just created this generic UI view. I put the image view in there. I'm going to have to manage the size myself. I'm not going to do auto layout in there, et cetera. And basically, I'm just going to always set the image view inside to be the right aspect ratio for my image, but no wider than my container view. And if my overall controller gives me no space for the view image, then I don't get it. Okay? And also, anytime my image changes, I'm going to ask for more space by resetting my preferred content size. Remember preferred content size for the popover and so I'm going to ask for more space. I may or may not get it because popover might be near the edge, but I'll ask for it, and we'll see that code in just a second here. All right, so I got that. Here is some code. Let's put some code in here to do that. I have this extension that I added to my waypoint controller, and it has this method update image. Now, update image, the reason I snippeted this in here instead of typing it all in, you've seen it all before, right? I'm dispatching to another thread. I'm getting the image data. Here I'm getting the URL, getting the image. I'm dispatching back to the main thread. I'm setting the image in my image view. So you know this is just, it's not worth our time to go through this again. We've done this 2 or 3 times. But I am calling this function here make room for image. And all the make room for images is just, it sees if the image is any bigger than the last image we had. And if so, it updates the preferred content size to give it a little bit of extra height. And this extra height might be negative if we just set the image to nil, for example, might try to collapse it back down. So again, this is just saying what we prefer our overall content size to be. And if we can get this space, then my generic UI view that contains my image is going to get bigger, and there's going to be more space for me, and I can make my UI image view bigger. See more of my UI image view. Okay, so that's it. So we do need to update this image. We'll do it in update UI, right? So we have update UI up here that updates the text fields. So we also want to update our image there in that as well. Okay, so that's it. That's how all is necessary here to display the image in my view controller and keep its size contained. So let's go ahead and kind of put a test image into our edited waypoints just to see if this is working. So I'm going to go back to GPS view controller, and where I add a waypoint here by dropping, I'm going to say waypoint dot links let's append. I'm going to append a new GPX link. That's the thing that has the reference to a URL, the URL to the image or whatever. And so we'll do HTTP CS193P Stanford images panorama. Okay, we'll just pick. I'm just picking one of the ones we had there at random. So now this waypoint has a link. Okay, just like the waypoints that came out of that GPX file, they have links also. One other thing we're going to need to do is over here in our MKGPX, right here, our editable waypoint. Right now, it gets its thumbnail and image URL by looking them up by this type thing, thumbnail type, large type. And just for the purposes of the demo, I'm going to make it just return the first link in its list of links. So let's go down here and just say return links.first.url. And then we'll have the thumbnail be the same as the image URL. So it won't have a separate thumbnail. I'm just kind of cheating this real quick so that we can see some image in our UI. So let's go ahead and run this and see what happens. See if this works. Oh, we got, what do we got? Oh, sorry, overrides. We got to override these. Override. Okay. All right, so I'm going to run this here in the simulator. We'll switch the device in a second here. All right, so here we are. You all remember this UI I've got here, and got these images on the left for there. So I'm going to go ahead and drop one for an editable waypoint here. So I'm going to click on it. You can see, and there it is. There's our panorama. See, I used that as the default image. And if I click our little editor here, there's panorama. It appears. Okay, so that's kind of fun. And notice that that's a very wide aspect ratio, but it only made enough space to do that, and so we can edit it. So now we want to be able to change this view. We don't want it to be panorama. I just showed that just to show you how this would work. So we need to go back to add some UI, some button that lets us take a picture with the camera and put that here instead. Okay, so that's what we're going to do now. Let's go to our storyboard here. I'm going to put that button like right here, I think. Let's move this over a little bit. I'm going to put it right in here. I have a nice button for that, or an image for that with the camera. So let's go ahead and get a button. Oops. Okay, here's a button. Sorry, small screen. Okay, so put this button right in here. Okay, I'm going to set this button's image to be that camera. So let's go ahead and drag that camera image into our XC assets. So here's our image assets. Drag this guy in here. Okay. We could put higher resolution versions in, et cetera, but we're just going to use that. So let's go to button here. I'm going to go to the button here and change its image to be the camera. And I don't want the word button on there. Okay, so here's my button. Now we'll do some auto layout here to get this thing in here. So I will put this up against this edge. Let's put something between here, the horizontal spacing. Let's have these two be center Y. We had another one in here that we'll have to delete now because we used to have this thing on this edge. So let's go find that. That's trailing space to super view right here. We'll get rid of that. We'll make these to be standard spacing right there. All the rest of it looks like it's standard. Must have lined them up perfectly there. Any problems? Oh, horizontally ambiguous. Okay, so this guy wants to hug. The button wants to hug itself because this guy is willing to be as wide as we want. It doesn't want to hug down, but this one does, and the system has to know who gets the space there. So now the frames will be different. Okay, let's go down here, update our frames, make sure everything looks good. It does. Okay, excellent. So we've added this little button to our UI. So now we're just going to have this button. When we click it, it's going to bring up the camera. So let's go do that. All right. I'm just going to control drag from this button right here and here. And it's going to be an action. We'll call it take photo. That's what it does. And oops, and we don't need any argument or anything. There's take photo. So in here, all we need to do is create that picker and present it. And then we're going to implement those delegate methods and we'll be good to go. All right, so what do we need to do in here? First, I'm going to check and make sure I have a camera. Actually, first I'm going to go and give us some space to work with. All right. So first, I'm going to check here and see UI image picker controller. If I have a camera available, so I'm going to say source type available camera. Okay, so if I have a camera, then I'm going to set my picker's source type to be the camera. Okay. What else do we got? Oh, sorry. Got to create my picker. So here I'm going to say let the picker equal UI image picker controller. So when you create it, it's just parentheses, parentheses. You don't have to specify any extra information when you're creating it. So now I've set the source type. Now here I would maybe, if I was doing video, I would check media types to make sure that that media type is available, and then I would say picker.mediatypes equals, and then the types I want. So in this case, I just want image only. Okay, and then we obviously need the picker to set its delegate to be self. Okay, without the delegate, this thing does nothing. We could also set some other fun things here, like maybe we allow editing. True. So we'll see what that UI looks like. And then we can just present view controller, the picker, animated yes, and we don't want to find out that after it's been put up. And what else do we got in here? Oh, okay, so this is the famous, where's this come from? So we have to come up here, import mobile core services. Okay, take care of that. And this one, of course, is we don't implement UI image picker controller delegate. Okay, let's do that. UI image picker controller delegate. Now, what's interesting here is that we still have an error once we put this UI image picker controller delegate thing here. It says waypoint controller does not conform to UI navigation controller delegate. Why the heck does it say that? UI navigation controller, I don't have anything to do with that. Well, that's because the UI image picker controller is a UI navigation controller, it inherits from it, and they use the same variable delegate to be their delegate. So we also have to go up here and say that we are a UI navigation controller delegate, even though we don't actually implement any of these methods in the protocol. That's fine, they're all optional. Okay, so that's a little tricky thing. Sometimes people don't understand that with the picker, but you definitely need to do that. So that's all that's required to put that picker on screen. So it's going to be on screen, and now we just have to implement those delegate methods. So here they are. This one, by the way, is deprecated. Don't use that one. Here's the one where they picked something, and here's the one where they canceled. Okay, so let's do the one where they picked something. So I'm just going to say that the image they picked is the info, okay, that info dictionary that's being passed along here. And there's a bunch of constants in UI image picker controller, and one of them here, image picker controller edited image. So that's the edited image, and I want to get it as a UI image, okay, because this info is, any object is the value, so I have to cast it here. If I couldn't get the image, okay, the edited image, then I'm going to try and set the image equal to the unedited image, which is the image picker controller original image as UI image. Now you might say, well, why am I doing this line of code right here? Because I'm clearly allowing editing up here. Yeah, we're allowing editing today, but if I someday said, I'm not going to let people edit, and I change this to false, well, all of a sudden this code would break if I didn't have this nice little thing here. So I'm thinking ahead a little bit to make it so that a change somewhere else in my code won't break me here. Okay, and so I've got the image. So I'm just going to set my image views image equal to that, and I'm going to make room for it. Okay, that's this make room for image that I told you I added down here. Okay, and that's it. I've got everything, so I'm just going to dismiss. Notice I'm not saying presenting view controller dismiss here because I am the presenting view controller. So I'm just saying dismiss, true, and completion, no. Okay, we have to do the same thing here for the cancel case, okay? But in the cancel case, I'm only going to do this dismiss right here. Okay, obviously I'm not going to grab the image or anything if they canceled. All right, so let's take a look at this. Let's look at this, let's go on iPhone 6 Plus here. There it is. Okay. Actually, let's go. Still have our little panorama in here. Let's get rid of that real quick. That's over here. So we'll just go back here and we'll comment this out so that if we're testing again in the future, we can go back to it. All right, but let's get this code back up on the screen here so you can see it. All right, so here's our photo stuff. All right, so let's run again. All right, so I'm going to drop a pin. Notice that we don't have an image right here. Okay, I took away that little test image. I'm clicking our edit thing, and we've got this big space. Now, there's that big gray box right there because I set that UI image in my storyboard to be gray, right? So let's go look at that. See over here, this is gray. So really, when I'm shipping, I'm obviously going to go here and set this back to its standard, which is clear, basically. Okay, back to our code. All right, so we're going to take a photo here. I'm going to press that little camera, okay, camera. And you can see the camera comes up right here. And let's go. This was helicopter skiing, so let's look at our favorite hat, ski hat. We got our favorite ski hat. This is R2-D2. Actually, it's better than R2-D2 there. Little San Francisco Giants R2-D2. Okay, so we're going to take this picture. Okay, so we can now crop it. Okay, we could zoom in on the really important part, right? And then we can say use photo, and it comes back and it appears in our thing here. If we take a different picture, maybe we decide, okay, we want the whole hat. All right, we'll zoom it there. We'll use that photo. We got it. Okay. Now, of course, this is not going to save this. So as soon as I go away and come back, it's not there. And that's because we need to save that picture somewhere. And we're going to save that in the file system with our next demo. Let's take a quick look at what this looks like on the iPad. Make sure that it works over there as well. All right, so we'll drop a pin here. We'll go there, bring up our little popover, take a photo. Again, we get the huge size screen. Oh, we'll have to do front-facing camera because I get it on this thing. Here we go. So R2-D2 hat there. There we go. All right, and there it is. And so it put it into our little popover, which is kind of fun. And because we had that generic UI view, and I asked for a bigger preferred content size, it made some more size, and then the generic UI image view got bigger, and so then I was able to make the image view inside it bigger. Okay? Excellent. Okay, let's go back to the slides and learn a little bit about storing stuff, and then we can come back and store that image. All right. So there are a number of ways to make things persist on your device. In other words, some data that you want to live forever on your device, okay, even as your application is quit, the phone gets powered off, whatever, you want that stuff to exist. So I'm going to talk about 4 different ways. You already know one, actually, which is NS user defaults. Okay, that's a really simple, kind of small amount. This is for bigger data, these 4 things. The first 2 I'm just going to really briefly pass through. I'm barely even going to talk about them because really you're certainly not going to use them, I don't think, in your final project. Maybe some SQL master out there will be doing some SQL thing, but I don't think anybody uses that. But then the file system and core data, I know a lot of you are doing core data as your final project. I think that's a great not covered in lecture thing, by the way. Even though I'm going to talk about it today, that doesn't mean I'm covering it in lecture. I'm barely going to talk about it. But so I know a lot of you are doing that. And some of you want to use the file system also. You're reading and writing files from the file system. So hopefully this will get you up to speed there. So let's talk about archiving. Archiving is a way to store a graph of objects, okay, onto disk. And those objects don't have to be property lists. So they don't have to be array, dictionary, date, whatever, because that's all we can put in NS user defaults, right? And NS user defaults for small things. What if we want to store big things, bigger object graphs, and we want a lot more flexibility? Well, that's where we use archiving. And archiving can archive any tree of objects as long as all of them implement these 2 methods, encode with coder and an init method that reads themselves back in from a coder. So encode with coder basically writes themselves out basically as a dictionary. Okay? And then init will instantiate the object when it gets read back in, reading the stuff from that dictionary. So where is this used? Your storyboard is archived. So all the things in your archive, all those UI views, all those UI view controllers, they are all encodable. Okay? They implement this NS coding protocol. And they all get written out. When the storyboard is saved, this whole object graph, the entire thing, all the buttons, everything in there gets written out using this archiving mechanism. And that's why we had that weird init thing with UI view controller and UI view where there was always this required init coder thing. That's because they participate in this archiving. Now, I would not recommend to you if you had a graph of objects and you're like, oh, I want to make them persist. I think I'll archive them. I wouldn't do it. I would use one of the other mechanisms I'm going to talk about today. Okay, this was great for storyboards, and it really is the right thing for storyboards, but I'm not sure for arbitrary data storage it really makes a lot of sense. Okay? All right, SQL. Some of you are database experts, and there is SQLite on the iPhone. SQL is, for those of you who are not database experts, SQL is basically just a programming language for databases, okay, for creating tables and columns and rows and tables and all that. And you can, if you had a bunch of code lying around that knew how to write to a SQL database, then you could certainly use SQLite. And the next thing I'm going to talk, or the thing I'm going to talk about at the end here, core data, it uses SQL underneath. Okay, it's writing all its data to an SQL database as well, but probably not going to access it directly. The interface, the programming interface to SQLite is like a C API. It'll work in Swift because Swift has compatibility with C APIs. But it's a little hard to use because it's going to have weird things like, pointers into memory and things like that that Swift doesn't really. It has ways to adapt to this so that you can do it, but it's not really native. It's not part of Swift's way of doing things. So it'll be a little odd for those of you who are used to Swift to try and program this SQL API using Swift, but it can be done. You'll have to look up how to do it. All right, so the last thing I'm going to talk about is the file system and core data. So the file system is very simple, okay? Your device, your iOS device, has a Unix file system, okay? Because I told you in the very first day of this class, basically Unix is underlying, a variant of Unix, BSD, Mach, is underneath all of iOS. It's providing the kind of core OS services. So you have a Unix file system there, and if you want to store things in the file system, you just store them in this Unix file system. Now, it's kind of 4 steps to do that. One is you have to get the root path to some URL, file system URL, not an HTTP URL, that you're going to write or read from. Okay, so you basically got to start somewhere in the file system. Now, it's a Unix file system. Of course, it starts at /, but you can't write in /. That's the root directory. You have to write somewhere down /something/something/something. That's where you get to start. So finding that root path is the first step, and we'll show you how to do that. Then you're going to append path components onto that URL. So if you want to create some directories in that place and then some files, you're going to be using appends, and SURL has some methods to do that. And then you're going to read and write files from that URL. And we'll talk about how you do that. And finally, you're going to manage the file system. You might want to remove a file. You might want to rename a file. You might want to see what files are in a directory. And that's all done with this class NS File Manager. Okay? So that's it. This is how the file system works. So let's look into all of these steps. So you see this file system. It starts at root. It's a protected file system, though, so you can't see most of the stuff that's in root or any of the system directories or whatever. It's just it's not readable by you. So there is a part of the Unix file system there, though, that is your application's own. It's called its sandbox. Okay? And this is the only place you can write. Some of the places in your own sandbox you can't even write. Like the place where your actual application is, you can't write there. So you can't modify your own code by writing something in that directory or something, okay? But many of the directories, subdirectories of your sandbox, you can write in. So this is the place where you're going to write. And you can read everything in your sandbox. So we'll talk about how you get a URL into your sandbox in a second. Now, why do we do this sandboxing thing? For obvious reasons, for security. You don't want to be able to look into other apps and see what's going on over there. And you don't want to be able to access the system directories and mess up the iPhone, so it's completely obvious. But there's one slightly non-obvious reason to this sandbox, is that since everything you are ever going to write on the local disk is in this sandbox, if the user deletes your app, you know, they go over here and hold down till the thing, oh, it's the other one. Which one are we showing? Yeah, this one. See them wiggling there? So if they hold down and wiggle, if they were to press X to delete it, it would delete your entire sandbox. So everything you've ever written is gone. Okay? Also, that's true for backup. If they back up their phone to iTunes U, okay, or iTunes, not iTunes U, iTunes, then it would back up certain directories in your sandbox, not all of them. Okay? So that's another reason to have this sandbox. So what's in there? What's in the sandbox? There's various bundles, which are directories. There's the application bundle I talked about. That's where your actual app is. Okay? And everything there is read-only. All your storyboards in there. If you have JPEGs that are in your image assets, they're all in there. They're all read-only. If you put something in there you needed to edit, like maybe some SQL database or something you put in there, or some data file, you would have to copy it out of the application bundle into one of these other directories in your sandbox, and then you could edit it there. Okay, so you can ship your app with things you're going to edit, but you just have to copy them out of your application directory. And then there's also other directories in there. The documents directory, that's where you should store what the user perceives as their data. Okay, the things they're creating and editing, owning, that they expect to be there all the time. That's, even if you don't kind of divide it up into a document in your UI, it's still, that's what the documents directory is for. There's also a caches directory. This is for data that you could throw away. So it's some information you got from the internet that you could go back to the internet, but it might be slow to go to the internet, so you're going to keep a local copy, but you could throw it away. That directory, for example, wouldn't get backed up to iTunes, okay, if someone plugged their phone in, because they figure you can recreate it, okay? And there's a bunch of others, about a dozen different directories. And you find all these directories by looking in the documentation for the term NS search path directory. Okay, and I'll talk about that in a second as well. So how do you get the URL to these special directories in your sandbox? You do it with this file manager class, this NS file manager. Now, NS file manager, there's actually a class function called default file manager that will give you the default NS file manager. The only thing to be a little careful about that one is NS file manager is thread safe, and a lot of times you might want to read and write a very large file in a different thread. Okay? And NS file manager is completely thread safe, but only for an NS file manager instance that is created in that thread. In other words, you should never create an NS file manager instance in one thread and then use it in another one. That's not thread safe. Okay? But even if you're accessing the same files, trying to remove or look at the same directories, that's all perfectly fine as long as each thread has its own NS file manager. So the NS file manager, default file manager, you'll see that in the documentation. That one is kind of your main thread default file manager. If you're only going to use it on the main queue, then you can use that one. Otherwise, just create an instance. It's pretty lightweight to create an instance of NS file manager, just like this. Okay, let file manager equal NS file manager. So once you have a file manager, then you can send it this message, URLs for directory in domain. And that will tell you, it gives you actually an array of all the documents directories, all the caches directories, all the application bundle directories. Now, why is this an array? Well, on iOS, it doesn't matter. There's always only one thing in this array, okay? And that's the users documents directory, the users caches directory. And that's because on the iPhone, you only have the users resources. But this API works on a Mac as well. And on the Mac, you might have the users documents directory, or caches directory, let's say. You might have the computers, and then you might even have the networks, okay? The local networks library. So that's why you might get multiple of these. So don't be freaked out by the fact that this returns an array of NS URLs. There's always only going to be one. You can just use the first one in there. And that is going to be a URL that points to this kind of directory, like the documents directory or the caches directory or whatever. And you specify which one you want with that first argument, NS search path directory. And you have to go look in the documentation and see what the special names of them are, but there's like NS Documents Directory, NS Caches Directory, NS Documentation Directory. By the way, be careful with NS Documentation Directory versus NS Documents Directory. I can't tell you how many final projects people post in Piazza and they'll say, I've been trying to write to my NS Documents Directory for days, but it says not writable. And it's because they've been trying to write to the NS Documentation Directory, which is read-only. Okay, that's documentation that ships with your app. So be careful with the escape completion there. NS Documents is the writable one. Okay, NS Documentation is documentation. All right. So now you have a URL to the root of one of these things, like the Documents Directory, the Caches Directory, and now you want to write some files in there. Well, you're going to use URLs, NS URLs methods, URL by appending path component, or URL by appending path extension. So an extension is like .jpeg or whatever, .doc, some document format of some sort. And so that's how you're going to do that. And by appending multiple path components, you can build things inside directories, right? So I can say a path component today's documents, and then path component foo, and that would be a directory today's documents, and inside foo. Okay, so that's how you build up the URL. So once you have a URL, you can find out some things about it, like is this a file URL or is this a network URL? Sometimes you want to know that because you're accessing an image and you want to know whether it's on disk or whether it's on the network. You might put one in a thread. Because some people ask, should I always access my file system in a thread? And the answer is, probably for small files, unless they're megabyte-sized files, you're probably fine to access them in the main queue. It's pretty fast. That flash memory is pretty quick at getting the information back. So you probably don't need to do that. Couldn't hurt, especially if you already have the code to deal with the fact that the file might be over the network. Might as well do it for the local file too. But there's also a very important method that's a little bit buried in the documentation called resource values for keys. This is how you get things like, when was this file last accessed? Okay, how big is this file in bytes? Okay, that's this NS URL thing, resource values for keys. And you give it the keys, like file's last change date or whatever, and it's going to return a dictionary rather, with those keys you gave and the values for all those things. Okay, permissions, all that stuff, resource values for keys. All right, now I got a URL. I want to write to the file system. How do I write something to the file system given a URL? And the answer is usually you're going to use NSData. Okay? You might use the property list ones like NSArray and NSDictionary and write a property list out to it. But you're oftentimes going to use NSData because you have some image data or some other data you want to write out, sound file, something. And so you do that with NSData's method, write to URL atomically. And so write to URL, you just give it a URL. It will write that file out there. And the atomically means write a temporary file and then remove the old file and put the new one in an atomic transaction. Okay, that way, if something happens in the middle of writing the file won't be half written. Okay, it'll be always a completely written file, and it'll return a Boolean as to whether that was successful. Okay, so that's the primary way you're going to write. That's how we're going to do it in the demo. That's the #1 way you're going to write. I told you that NS File Manager could do other things too, manipulate the file system, create directories, things like that. You're going to have to look at the documentation. There's quite a few functions in there. It also has a delegate where it'll let you control things. There's like should write file at path, things, something along those lines where it's basically shoulds that you can control whether something happens. And so you can look all that up on documentation. It really doesn't make sense for me to go over it all here. Okay, so that's the file system, and I will be demoing that in a moment in tracks. But first I want to talk about core data, the last persistence thing. How many people here are doing core data for their final projects? Wow, okay, so half of you. That's great. I'm really, really, really happy about that, because I didn't teach core data in detail this quarter, so I was hoping a lot of you would do it as your final project, because core data is actually an important thing to know, not just as a way to store data, but it's just conceptually understanding a little bit more about how iOS works and things like that. Core data, if you can figure out how to do that, then you've understood a little more about how iOS works. So for those of you who are not doing core data, I'll go through this quickly since most of you are doing it, but what is core data? It's basically a way to store your data in a SQL database, basically, but in a totally object-oriented way. So you don't have to issue any SQL commands or anything like that, create rows and tables. It's going to create all that for you. It's a completely object-oriented API. It's a very powerful framework in iOS. It has a lot. Most of you who are doing it for your final project even are only going to touch the basic thing of setting properties and creating entities, but there's a lot of really powerful querying things that can happen in there. Most of the things you can do with SQL, you can do up in the core data layer. Things like optimistic locking and all that stuff is all doable. So it's a pretty powerful mechanism. It is backed by SQL, but it can also be backed by other things, XML, or you could even actually get involved and store the data in your own format, but that would be very advanced usage. So how does it work? How does core data work? You create this visual mapping in your schema. Okay, it's not like the parse that you saw at the Friday section a couple weeks ago. That's schemaless. It's basically creating its schema on the fly. Right? It creates the rows and tables as you ask for them. This one, you define your schema up front. What are going to be your objects and what are going to be the properties on those objects. And then basically, tables are kind of like classes, if you want to think of it that way. And then the columns in the table are kind of like vars. Okay? And then core data provides a way to have these @NS-managed vars where literally you just set the var and it's going to go set the information in the database. And then, of course, you can query on all this stored data as well. You create the schema with this visual map. You do new file and you create this thing data. You choose this thing data model. You're going to get this thing. It kind of looks like this. Okay? It's a graphical piece of graph paper looking thing. And you can actually create things that look like classes, like photo and photographer here. And then you can create the columns in the database. And then you can create relationships by control dragging between them. So you're going to create your schema totally graphically there. Then you get this UI managed context. That's kind of your handle, your hook on your database. There's a couple of different ways to do that. There's some code that can be generated when you create your project. You can click on the Use Core Data button, and it'll create this code for you in your app delegate. And it'll have a method in your app delegate called Managed Object Context. Now you have a handle to your database, and you can start creating objects in there or setting the values of things. There's also another class, an important class called UI Managed Document. It's a way to encapsulate a core data database. Okay? What's really cool about UI Managed Document, if you use that approach versus the Use Core Data approach, is that the iCloud side of it becomes a lot easier. So if you wanted to have your core data database work on iCloud so that I could see it on all my devices and it would be automatically synchronized, then you want to use UI Managed Document. So maybe some of you, anybody trying to use UI Managed Document? Okay, so that's kind of like the next step you would think about doing in core data. All right, so once you have this context, the handle on this core data database, you can create objects. You do that with this NS entity description class method called insert new object for entity for name. And you're basically just specifying the name of the table, which is like a class. And you give it the managed object context. And it will create a new instance, okay, a new row in that table, to use the database terminology, and it's going to return to you this NS managed object or a subclass thereof, and it's with this NS managed object that you can set the columns, set the values in that row. You can also fetch. You create these things called NS fetch requests. They basically specify what you're looking for, pretty powerful predicates in there for saying, well, I want all things, all of the rows whose column it's called name starts with the letter A. You can do that kind of fetch request, and then you issue the fetch request and you get it back as an NS array. This fetched object thing would be an NS array or an array of NS managed object. Okay? And so that's kind of what you can do with the database. Once you have these objects, these NS managed objects, you can use these two methods, set value for key and value for key, to set and get the values in there. Or even better, you can create subclasses of NS managed object that have these @NS managed object vars, and core data will automatically make it so that if you set that var, it sets it in the database. And if you get that var, it'll fetch it from the database. Okay? You use normal Swift notation for that. Okay, so that's kind of what core data is about in its core. pun intended, no pun intended. Core data is also really good at hooking up to table views. Because you can imagine you got these big tables of data in core data, and it would be nice to have a table view that is displaying all the rows or some subset of the rows based on some query in the table view. And so there's this class called NSFetchedResultsController in iOS. It's a super simple class. It basically, you give it a fetch request, and you associate it with the table view, and then that table view will always show what that fetch request would fetch, even if the database changes out from under it, okay? Because you add something, and if the thing you added matches that fetch request, boom, it'll just automatically appear in the table, okay? So you don't have to be doing all, basically Fetch Results Controller will implement all of your UI table view data source methods for you. How many rows in table, how many rows in section, give me the self or row and index path. You have to do your own self or row and index path to do the UI part of it, but there's just one method in the Fetch Results Controller that will tell you which managed object is in this row in the table. So if you're doing core data and for your final project and you're doing table views, you definitely want to look up NSFetch Results Controller, okay? All right, so the demo that I'm going to do, I'm not going to demo core data. Don't have time for that. So I'm just going to demo the file system piece. And we're going to do that by making our waypoint store the image that we took with the camera as a JPEG in the file system. And then we'll have a URL to it. We can update the waypoint. And our new edited waypoints will work just like the ones that come in a GPX file. All right, so what do we need to do this? Really, all I'm going to do here, when I take a photo, okay, and the information comes back in the delegate, I'm just going to say save image in waypoint. Okay, remember that this MVC, its model is the waypoint that we're editing. So I'm just going to have a little method here, save image in waypoint. So let's implement that, save image in waypoint. And all we're going to do here is we have the image. We already got it, put it here in our UI view image, so I'll just get it out of there. And we're just going to write it in the file system, and then we're going to update the waypoint to use that URL. Simple as that. So if we can get that image, so if our image view has an image, okay, because it could be nil. It might have been set to nil by some means. Then I'm going to get the image data as a JPEG. And the way you do that, there's this cool function, UI image JPEG representation. And you just give it a UI image, okay? And you give it a compression quality. So I'm going to do really high compression, okay? So this is a quality between 0, I think, which is like the most compressed you can do, to 1, which is like almost no compression, okay? I think that's the direction it is. I hope that is what it is. But anyway, so you can look at the documentation for it. But we're going to turn our image here into, by doing this, an NS data. So this is going to return an NS data. If we look at the up here, see that's the NS data. So it's going to turn our image into an NS data. It's kind of the opposite of NS data contents for URL, which is the opposite. It would take a URL for some data and turn it into a UI image. This goes back the other way for JPEG. So if we're able to do that conversion, then I'm going to get a file manager here as a local variable. I could just constantly, I could use the default manager by default manager. You see, I'm in the main thread. But just in case I ever put this in a separate thread or something, I'll go ahead and use an instance of it here. So now I need to get the documents directory, because these waypoints, really the user perceives them as their document data. That's where you would want to store this. It's not like a cache that we can never get back. We need that photo. If we lose it, it's gone forever. So, and again, we might really want to be saving this in the photo library, but I'm just trying to demo here how to do the file system, so that's why we're doing that. So I'm going to get the documents directory. And so here's a nice long line of code for you. So take the file manager. We're going to get the URLs for directory. Okay, the directory we want is the documents directory. And the domain always on the iPhone is the user domain. More space, please. The user domain mask here. Okay, so that's going to get this array of URLs, and I'm just going to get the first one out of there. Okay, and then I'm going to make sure that it's cast to URL. So if all of this succeeds, then I got the documents directory. And what did I miss here? Documents. Oh, document directory. There we go. Okay, so this will end up being a NSURL that points to the document directory. Okay, so now I have a documents directory. I need a unique name for this photo that I just took. So I'm going to create that by just saying NSDate time interval since reference date. So this is a certain number of seconds. This is just a unique number. It's going to be a double that unique identifies this photo because you can't have two photos taken at the same instance in time. So we got that. And so I'm going to let the URL for my photo be the docs.dir and then URL by appending path component. And then I'm just going to create a string out of that unique. And we'll say that it's a JPEG. Okay, so now I've created a URL, which is just this unique string with JPEG on the end. So now if I can get the path to that URL, so this is going to take the URL and turn it into a string. Okay, because URLs are NSURL objects. I want the string. You'll see why in a second here. If I can get that, then I'm going to take that image data and write it out to that URL. And I'm going to do it atomically. Okay? And if that succeeded, if I was able to successfully do that, then I can add it to the waypoint by saying waypoint links. And I'm just going to replace all of my waypoints links with a GPS link, which is href of that path, the string version of the NSURL. Because GPS link, it's a generic GPX parsing thing. It takes strings. It takes URLs as strings here. Okay? Everyone understand all this code? This is typical code for writing something out into your file system, into your sandbox. In this case, the document directory or sandbox. All right, so let's go ahead and run that. Let's go do it on the iPhone here. Okay, so let's drop a pin here. And we can see that we have our dropped there and we have no image yet. So let's click on our little eye here and get an image. So I'm going to click the camera. Let's get a picture of our R2-D2 hat here. There we go. We're going to use that photo. And now we have our image. We could even, for example, change our title here maybe to, let's say, R2SF. All right, we click done. Now if we click on our pin, we can see that the image has been saved, and we can see it there on the left. We can even click on it, scroll around on it, okay? Or go back and edit it and take a different photo if we wanted to. Okay, now, by the way, to make this work, I had to make a small change to the code, which is right here. In did select annotation view, we just want to make sure that if we have no call out accessory, because we started without one, when we drop a new pin like this, we have no image, and so it didn't add the left call out accessory in that case. So just when the annotation is selected, we're just going to make sure that it adds it. Okay, back to our slides. All right. Okay, so the last thing is embed segues. So embed segues is just taking the view, self.view, basically, of an MVC and putting it in another MVC's view. Okay, so it's basically embedding one MVC into another. It's a pretty powerful encapsulation technique. The way you do it is really easy. In the storyboard, you just drag out this thing called a container view. Okay, you drag the container view out, it's going to be a little view, and it's going to have a little MVC attached to it. All right, so it looks like this, right? When you drag it out, that little gray thing that says container, that's the thing I dragged out from the storyboard, and then that little arrow there moving, that's the embed segue. And you can see there's another MVC there, and that MVC is the one whose self.view is going to be embedded. All right? The timing of this, you got to be a little careful and prepare for segue because this embed all happens before any outlets are set, as usual. And so it's happening very, very early in the game. So usually in our embed segue, what we do is we grab onto that MVC, okay? So that we have a handle to it. We can talk to it, we can prepare it, set it up, whatever we want later. So this is best shown by just demonstrating it. So I'm going to demonstrate that by going into tracks, and here's our tracks UI. So tracks right here, this is our map view right here. And when we click on the left edge of a call out, it brings up this UI image view controller, right, which is currently fully contains an image. And what I'm going to do is I'm going to embed in the corner a little rectangle down here, a little square, that contains a little map view with just the pin for this image. So that when I'm looking the image, especially on the iPad where I got a big screen, I can see some context of where this image was taken, right? So I'll see them both on time. So I'm basically going to embed another view controller into this guy right here. So what do we need to do that? Well, the number one thing we need to do when we have an embedded view controller is we need to do this segue, and we need this view controller right here to have a little subclass to manage that. So right now, this view controller, as you know, is an image view controller. So if we select this, you can see that its class is image view controller. So I need to change this. I'm going to change this to be a waypoint image view controller. Okay? So a waypoint image view controller is going to be a subclass of image view controller. So it's going to do everything this one does. Plus, it's going to know about how to manage that embed. Okay? So let's create a new class. Right? The Cocoa Touch class. It's going to be a subclass of image view controller, one of our classes. And I'm going to call it waypoint image view controller. Okay? Put it in standard place. Okay, here it is. Here's our waypoint image view controller. This waypoint image view controller, its model is the waypoint. Okay, this guy's model, does everyone remember what image view controller's model is? It's just an image URL, right? So we need a little more powerful model here in our waypoint image view controller. So I'm just going to have var waypoint. It's a GPX waypoint. It'll work with the editable ones or non-editable ones. And when that waypoint is set, I want to make sure that I set my superclasses model. So I'm going to say my image URL equals that waypoint's image URL. Okay, so here I'm basically setting my superclasses URL there. And what are we getting this about here? Oh, okay, we're not there. Okay. And then I'm also going to set my title equal to the waypoint's name. Might as well. And then I'm just going to update my embedded map. Okay, because the whole point of this guy is he has this embedded map. So we'll have a function here called update embedded map. And it's going to update that map. And we'll talk about how that's going to happen a little bit later. This is an optional, that's why. Okay. All right, so that's it. So that's our waypoint image controller, kind of its main thing. So now we need to go back to our storyboard, and I'm going to make this image view controller right here be a waypoint image view controller. So I'm just going to go here to its identity and go down here and say, now it's a waypoint image view controller. Also, I'm going to fix this segue. This is a segue from our map view. I'm going to fix this one to prepare this guy by giving his waypoint. So that's over here in our GPX view controller. Down here in prepare. Okay, here's where we're preparing the image view controller. Okay, so here I'm going to say if I can let the waypoint image view controller equal the segue destination view controller, content view controller, as a waypoint view controller. So in other words, if it's a waypoint image controller, then I'm going to say waypoint image view controller waypoint equals my waypoint. And actually, I'll just go ahead and leave this other code in here as an else. Else if it's not a waypoint view controller, it's just a normal image view controller, we'll still make that work as well. But we could delete this code and it would work fine now. But I'll just leave it in there just for reference. Okay, so now we need to go do this embedding business. Okay, we need to put this thing in here. Now, one thing I'm going to advise you to do when you're doing embedding and kind of be a little careful of is when you drag out this container view, which is at the very bottom, by the way, it's going to want to be a sub-view of the thing you're dragging it on. So it keeps trying here to be a sub-view of that scroll view. And I don't want it to be a sub-view of the scroll view because I want it to sit on top. Okay? I want it to always be there. And the scroll view is scrolling behind it. I don't want it to be in there scrolling around. Okay? So it's really a bit of a pain to do that with this in the way. So you can just take something like your scroll view, for example, and move it out of the way temporarily. So I just moved it out of the way. So now I can put my container view in here. I can put it where I want. Probably not in the very corner there, something like that. I can do all my auto layout here. Maybe we'll do this a little bit higher. Yeah, let's do that. Bottom space. Probably I want this container to be a fixed width and height. Okay. I don't know what width and height I would want. Maybe like, I don't know, let's say 200 by 200. Sorry, don't look like there. So let's make it 200 by 200. We could make it whatever size we thought was kind of most appropriate for this space. And then we can put this back, the scroll view back. And by the way, if you go over here to the document outline, you can see the order in the view hierarchy. Like this would be behind, and this is in front of everything else. Okay? Scroll view, the activity indicator, and this container view. Now, I dragged this in here, but if we look, oh, look at down here. What's this guy? Okay? See, that is the little view controller, the could. This is the little view controller that is going to, whose self.view is going to be in here. So let's do this guy right here. We need a class for this, a view controller class for this, so I'm going to create that. This is going to be the world's simplest map view controller. I'm going to call it, in fact, simple map view controller. It's going to be a UI view controller. And all this simple map view controller is going to do is to make its map view outlet be public so that other people can do whatever the heck they want with the map view that's inside of it. So let's put a map view inside of it. Let's go back to our storyboard. Get this little guy right here. Okay, I'm going to, first of all, I'm going to make him be a simple map view controller like that. And then I'm going to put a map view, which is right here, inside of him. Okay, let's go ahead and go suggested constraints. Probably that'll be just fine. Yep, all looks good to me. And so let's just create an outlet for that. Oops, an outlet here. Small screen, there we go. Okay, simple map view controller, there it is. Let's control drag here, map view. Okay, so that's it. That's the entire implementation of this class. It's just going to do that. It does mapkit, so we have to import mapkit. Okay, and so this is just public, and we can do whatever we want with this map. So what do we want to do with this map? Well, we want this map to show our waypoint in our waypoint image view controller. Okay, so that's how we're going to update this embedded map, is where you can access the map view directly. But the one thing we need to do first is we need to do this segue right here. So we need to give this segue an identifier. We'll call it the embed map segue. And we need to prepare this segue. And we prepare it here by, we're going to prepare it just by grabbing that map view. Okay, grabbing that controller actually, and then grab the map view out of it. So I'm going to prepare for segue here. I'm going to say if the segue's identifier equals, and we'll just no constant here. Should do one, but we're not going to do. So it's the embed segue. Then if the actually, I'm just going to create a var here, which is the SMVC, the Simple Map View Controller, which is a simple map view controller, optional. And I'm just going to actually set it inside this prepare for segue. So SMVC equals the segue's destination view controller as a simple map view controller. So in the prepare for segue, I've just grabbed onto this simple map view controller. So now that I have it, okay, let's go ahead and update our embedded map here. And let's do the code for doing the embedded map. very simple. I'm just going to say if I can get that map view out of that SMVC, okay, then let's set the map view to be map type hybrid. And then we want to set the map view's annotation, so let's remove the existing annotations from the map view. And then let's map view add an annotation for our waypoint, okay, which remember is an MK annotation, so we can do that. And then let's also zoom in on those. So show annotations, the map views annotations, and yes, we want it to be animated. Okay, so that's going to update our embedded map. Yes, embed map. Okay, all right, so now that we're actually embedding the map and doing that actual prepare for Segue, we should get this to work. Here we go, and sure enough, there it is. And it's kind of hard to zoom out. Actually, I'm going to do this on the actual device. It's a little easier to pinch. Oh, I didn't hit play. There we go. All right, there we go. Here, we're there. We have our nice image here, and inside here, this MVC is a fully operational MVC. It can be pinched, it can scroll around, it does all the things that it would normally do, so we can actually see that we're in the Greenbush area, Greenbush Lake, all right? Okay, and if we rotate or whatever, it's all the auto layout works on it, etc. Okay, so that's embedded. Segue started to run a little bit long. If you have any questions, I'll be here as usual. I will try to endeavor to figure out what happened with our other thing, and I'll post later what went on there.
For more, please visit us at stanford.edu.